Alright guys, welcome to the second video for 6.1, Properties of Exponents. As I mentioned in the last video, our essential question is going to stay the same. How can you write general rules involving properties of exponents? However, in today's video, our learning objectives are different. Our first learning objective here is to learn and understand the negative power property. Our second learning objective is going to learn and understand the zero power property. So we're just adding two more properties onto the two properties that we learned from the last video. Please make sure that you are keeping the properties from the past in mind, because at the end they're all going to work together. So don't just fly by them. Rewatch the videos if you have to. Pause it, take it slow, do what you gotta do. So our first learning objective for today's video is the negative power property. Very similar to the last video that we did. We have a chart, and the first line is filled out. So let's go ahead and really analyze what this chart is trying to tell us. Up here in the original quotient in the numerator, I have 2 to the 5th. So I have 2 times itself 5 times here. In the denominator, I have 2 to the 8th. And so I have 2 times itself 8 times here. Now, based on the last video, I know that when I have something like this, where my bases are the same and the powers are being divided, I want to subtract the exponents. That happens from canceling out the 2's in the numerator and the denominator, and that's what's happening here. So we cancel a 2 in the numerator, 1 in the denominator, back and forth until we run out of 2's to cancel. And what I'm left with is 2 to the 3rd here in the denominator. And that's where I get this fraction right here, the 1 over 2 to the 3rd. However, in this box, I notice that if I go ahead and I apply that quotient of powers rule where I keep the base, but I subtract the exponents, 5 minus 8 gives me this -3 right here. And so my answer would be 2 to the -3rd power. However, something very, very important that I need you to keep in mind, and I would write this down, is that we want all of our exponents to be positive. So when I apply quotient of powers to something like this, and I get 2 to the -3rd, since I don't want a negative exponent, what I'm going to do is write the reciprocal of that guy. And so that way, my -3 becomes a +3. Okay, so let's go ahead and let's do another one. In our second line, I have 5 to the 3rd. So I'm going to have 5 times itself 3 times, and put that all over 5 to the 6th. So I have 5 times itself 6 times. If I do it by canceling, I'll cancel a 5 in the numerator, in the denominator, in the numerator, denominator, numerator, denominator. And what I'm left with is 1 over 5 cubed. If, however, I do it by quotient of powers, I see that here my bases are the same. So I'm going to do 5 to the 3 minus 6th power. That gives me 5 to the -3rd power. And again, since I want a positive exponent, I'm going to write the reciprocal as 1 over 5 cubed. And so you see here the answers are actually the same. The important thing is that we want those exponents to be positive. So if I ever get something with a negative exponent, I write the reciprocal. I'd like you to pause the video at this time and try the last two on your own, and then when you're all set, you can restart the video and see if your answers are correct. All right, so I hope that at this time you've worked on those 2 lines. In the third line here, we have a cubed in the numerator. So I have a times a times a. And I'm going to put that all over a to the 8th in the denominator. So I'll have a times itself 8 times. Extend this here. And then by canceling, numerator, denominator, numerator, denominator, numerator, denominator. What I have left is 1 over a, 1, 2, 3, 4, 5, a to the 5th power. And if I try to do this by quotient of powers, I see here my bases are the same. So I'm going to consider a, and then subtract the exponents, 3 minus 8. That gives me a to the negative 5th. Again, I don't want a negative exponent, so I write the reciprocal as 1 over a to the 5th. And again, here, my answers match. So that's a good sign. Finally, for this last row, I have x to the 4th in the numerator. So that's x times itself 4 times. Put that all over x to the 10th here in the denominator. So that's x times itself 10 times. 6, 7, 8, 9, 10. Extend this line again. By canceling out, I see that what I have remaining is 1 over x, 1, 2, 3, 4, 5, 6, to the 6th power. If I try to compute this using quotient of powers, I see my bases are the same as x, so I keep my base, subtract my exponents. 4 minus 10 gives me x to the negative 6th power. I don't want that negative exponent, so I rewrite it as the reciprocal, 1 over x to the 6th, to get that positive exponent. And look, again, my answers match. So based on the pattern that we see here in this chart, we can derive the negative power property. And that's going to tell us that 1 over a to the n is equal to a to the negative n, which is the same thing as saying if I see a to the negative n, I can rewrite that as its reciprocal, 1 over a to the n, and so that exponent will become positive, okay? So, verbally, I guess we can say when a power has a negative exponent, rewrite it as its reciprocal, to make the exponent positive. Okay. Just keep in mind that also means, let's say I have 1 over a to the negative n. The reciprocal of that would be a to the n over 1. My exponent is now positive, giving me a final answer of a to the n. So it works both ways, and it's very important to remember that. And this question down here, why is it important? I'm so sorry, my computer is just trying to get me to do all these things during this video. How do I get rid of this? Okay. The reason that this is important is because we don't want negative exponents. Okay? So there's your negative power property. We're going to move right along onto our second learning objective, the zero power property. So again, we have a chart. Let's go ahead and work through it. I have 2 to the 4th here in the numerator. So I have 2 times itself 4 times in the numerator here. Here I have 2 to the 4th in the denominator. So again, I have 2 times itself 4 times in the denominator. By canceling, I see that everything cancels. And when everything cancels, that leaves me with a final answer of 1. However, again, if I apply quotient of powers, which is the property from the last video, I see here that my bases are the same. So that means I can keep the base, subtract the exponents. 4 minus 4 gives me 0. And so my answer should be 2 to the 0. So one answer is 1 using the cancellation method, and one answer is 2 to the 0 using quotient of powers. So let's see if that continues to happen with the other examples. I have 5 to the 6th here. That's 5 times itself 6 times in the numerator. The denominator is another 5 to the 6th. So that is going to be all over the same thing, 5 times itself 6 times. By canceling, I'll see that everything cancels out, which means I get an answer of 1. But if I use quotient of powers, I see my bases the same in numerator and denominator, that's 5. I'm going to subtract my exponents, and that gives me 5 to the 0 power. If I look at my third example, I have a cubed in the numerator, and I'm going to set that all over a cubed in the denominator. By canceling, I see everything will cancel out, giving me a 1. But if I use quotient of powers, I see my bases are the same as a, so I subtract my exponents, 3 minus 3, and that gives me a to the 0 power. So based on the pattern in the above chart, okay, it is not a coincidence that I get 1s here and my base to the 0 power here. These are actually the same answer, okay? Which means that anything raised to the 0 power, looking here at 0 power property, anything raised to the 0 power is always going to equal 1. And if you don't believe me, plug it into your calculator. Plug in any number, 2, 4, 6, x, raise it to the 0 power and see what the calculator tells you. It'll give you a 1. So verbally, actually I'm not going to say anything. Let's be more specific. I'm going to say any base raised to the 0 power equals 1. And there's your 0 power property. Not too complicated, just something that we gotta make sure that we apply. So moving on to our last page here, we have some examples. Directions say rewrite as a single power with only positive exponents. You will have to use a combination of the 4 properties we have already learned, which again are product of powers and quotient of powers from the first video, and negative powers and 0 power from this video. So looking at example 1, I have x squared times x to the negative 2nd power. So this is going to be first and foremost product of powers. Okay, my bases are the same as x, so I know that I can go ahead and add my exponents. Well, x to the 2nd plus negative 2nd power, or maybe I said that kind of weird. 2 plus negative 2 I know is going to give me 0. So this is going to give me x to the 0 power. And so from here, I'm applying 0 power property to say that x to the 0 equals 1. So final answer, 1. Not too bad, not too bad. Looking at my second example, I have 3 to the negative 15th power times 3 to the 5th. First and foremost, this is going to be product of powers. These things are being multiplied. My bases are the same as 3, and I know that I can go ahead and add my exponents. So negative 15 plus 5 gives me negative 10. This gives me a 3 to the negative 10th. From here, I'm now using negative power property. Since I have 3 to the negative 10 and I don't want a negative exponent, I'm going to write this as its reciprocal. Remember, 3 to the negative 10th power is the same thing as 3 to the negative 10th power over 1. So its reciprocal will be 1 over 3 to the 10th. And now that exponent is positive. So my final answer, 1 1 over 3 to the 10th.